Again, in this video we'll discuss CBC mode. So this stands for Cipher block chaining. Oops. So let's assume the algorithms ED are encryption and decryption of a block cipher. So we can input a key K, and it's the same. So let me maybe state it. So D of the symmetric key K and E of K and the message M is equal to N. So if we first encrypt and then we decrypt, we get the original message back. And yeah, so maybe I should clarify a little bit more. So E has a key. Well, maybe let's call this some kind of calligraphic K, a key space and a message space, or rather, yeah, let's say message space, and this goes to M again, and E of some fixed key K should be a permutation. And and we want E to be a PRP, which stands for pseudo random permutation. But that's not that important now. Now we'll focus on what we can construct from E. So let me first show you the construction. So we have an encryption. We have input message, let's say M, which is equal to M1, and we have to split it into several messages. Okay, let's make it for simplicity in this case 3 messages, but this works for any number of messages. And so how do we encrypt in CBC mode? So at first we have the key K, we encrypt with the block cipher, and we get the first ciphertext. So now the question is, what comes here? Here comes an initialization vector, which we call IV, and I'll explain later why we do this. Then here we have M2, again in the block cipher. We get C2. What comes here? Here comes the first ciphertext, and then we go on like this for M3, and we would go on like this if we would have more messages. Okay, so here C3. Okay, now that's the encryption. Then let's see what the decryption is. So here we have first the IV, then we have C1, C2, C3. So C1 goes in here, then of course we decrypt in the block cipher with the same key K, and then we do this, and now this is similarly to before. So here we get M2, and now again the same thing as before. So let's check that indeed for our that decryption of encryption gives the identity map. So we want, let's maybe write it like this. So this should be the identity map. So let's see. If we have C1, we decrypt it using the block cipher. So we get out what we had as input here, and the input in here was IV plus M1. And if we add the XOR of IV, so let me maybe write it. So DK of C1 is equal to the IV plus M1. So if we decrypt C1 here with D, then we get the input here, and the input is the XOR of IV and M1. And if we add the IV here, then we get indeed M1. And similarly it's here. So if we decrypt C2 here, then we get the input here, which is C1 plus M2. And if we add C1 here, we get M2. So that works. So we indeed have an encryption scheme, which is correct. So it satisfies that if we first encrypt and then decrypt, that we get the identity. And now the question is, why don't we just use the block cipher? Why do we use this CBC construction? And the reason is the last video, basically. We talked in the last video about security against chosen plaintext attacks, and that's the reason why we don't want to use just a block cipher. So we use a random IV here, a random initialization vector, so that we get, so that all this here is random, and one can in fact prove that this gives a CPA secure scheme. So that's the reason why we use this CBC construction. There are also other constructions like the counter construction, which might even be better in some settings. But we focus in this video on the CBC construction. And also, as an important side note, so there was also the CBC with chained IV. What's this? This is basically, so here this is our whole message. And in the CBC with chained IV, we let's say have messages M1 as before, M2, M3, and let's say M2, which is, let's say, M4, M5, M6, M7. And then one could think, well, this works well if we just use the previous thing as IV for the next thing, because that's somehow similar to what we do here. So the idea would be we use a random IV for M1 and the IV for M2 is C3. And I hope you can get the general thing. So we take this as IV for the next message. And we can do this then with, let's say, C7 if we would have a third message, M3. But please don't do this. This is not secure. This is not CPA secure. And it can also lead to real-world attacks. So don't do this. And yeah, you might want to think about why this is insecure, because it's a little bit tempting to think that it's somehow similar to the CBC construction. And yeah, it might be instructive to think as an exercise about why this breaks CPA security. Okay, so thanks for watching this video. Have a good day and see you next time. Bye.